Hello, good evening. This is Mohammed Mbabi. I'm the Group Privacy and Data Protection Officer of a reputable banking institution located in the GCC. And this is my submission for the CAISO exam, the Certified AI Security Officer. I'm pleased to have you all with me, and please feel free to share any thoughts or questions after you have the chance to view the video. Please allow me also to review my notes in order to provide proper information about the content, and in order to make sure that the information delivered to you are most precise and accurate. Our video today is submitted in relation to the use of federated learning for privacy-preserving AI mobile applications. The scope should go in granular order in order for you to understand and get the necessary thoughts about the whole topic from the beginning to the end. Initially, to start this, we have to understand what is the use of federated learning. And in order to understand what is the use of federated learning, we have to understand what is initially and what is primarily what we call a machine learning. Machine learning is a branch of artificial intelligence that focuses on building systems that can learn from the data and make decisions based on the data that they learn from. There are many components of any machine learning system which are essential and necessary for this machine learning system to run. This is typically based on the type of data that it trains on and the algorithm, which is the mathematical method and list of procedures used so that this data is being analyzed. And then comes the training, which is the phase where the model learns from the data that it has as a subset. And then comes the phase where the model itself is initiated. After that, the features are being implanted or submitted inside the system, which is like the measurable properties or characteristics used inside the model itself in order to success. After that comes what we call the component of the labels. The labels in what we call the supervised learning are the correct answers versus which the model learns how to train themselves and how to build the knowledge. So this is actually the right answer for all the data or the questions that the model learns from. And comes after that what we call the phase of evaluation, which is evaluating the successfulness of the AI model itself or the machine learning model itself. And then comes the phase of deployment. After in this phase, the whole model is deployed and goes into production environment in order for it to go live. After this comes the latest phase, which is what we call the feedback loop. It's a situation or a phase of continuous improvement where bugs and mistakes and errors are being found out and submitted for correction. It's very crucial for the machine learning system to remain accurate and relevant. So the whole phase or the whole story doesn't end by the stage of deployment. No, after that comes a continuous improvement phase that allows the whole model to even grow bigger and learn from its own mistakes. To be able to understand what we call the federated learning, we have to know that it is a non-traditional machine learning approach. And in order to understand that, we have to know first what are the traditional machine learning approach. The approaches using which machine learning develops and starts are quite limited, but we can categorize them in 3 or 4 categories. One of them is what we call the supervised learnings, and which is where a trainer or someone takes the responsibility to train the model itself. And there is another model that we call the unsupervised learning. That's when the data is not labeled by what's right and what's wrong. Actually, the goal in here is to uncover any unhidden or any hidden pattern from the data itself in order to reach a correct conclusion in the end. There is also a third type or the third approach, which is what we call the semi-supervised learning, that combines both the supervised learning and the unsupervised learning. In addition to that, there are multiple other methodologies or approaches, such as reinforcement learning and dimensionality reduction. This might not be quite significant in the meanwhile to talk about, because we really need to move and talk about the core scope of today's session or today's video. As we have mentioned earlier, the focus is on federated learning, that is considered a non-traditional approach. Non-traditional approach often refer to more advanced methodologies of machine learning, such as, among which, of course, federated learning is one of those approaches. We would like to start with things like the methodology or the approach of deep learning that involves neural networks with many layers, and techniques like that do some sort of conclusion and recurrent networks, and transforms the data from like raw data into tasks. Like, for example, to be able to create an image recognition model. Another non-traditional methodology or approach is what we call the transfer learning, that involves taking pre-trained models and on large data sets, and then use them for specific smaller tasks. Another approach is what we call the generative adversarial networks. Another approach is what we call the self-supervised learning, where the model learns to predict a part of the input from other parts to the from the other parts of the input itself, allowing them to utilize vast amounts of unlabeled data. And this approach has shown great success in many aspects. Of course, last but not least, and the focus of today's session, is what we call the federated learning. Federated learning is a privacy-sensitive or a privacy-oriented approach, where a decentralized approach takes place as whole models are trained across variable and multiple devices or servers, holding their local data without sharing the raw data itself to the centralized server. So in that case, that every training model runs solely on its own device, like mobile device or a normal server or whatever, without sharing the raw data. In that aspect, we are doing some sort of a revolutionary precaution or a revolutionary methodology to maintain the privacy of the end users, that of course entail a lot and a significant amount of personally identifiable information. So, as we have mentioned, traditional machine learning approaches require centralizing the data in one spot or in one server. Unlike that, federated learning is where AI models are initially trained across decentralized devices or servers without sharing the data itself. This method definitely enhances privacy and security by keeping the data locally on each user or each trainer's device. So the core principle of federated learning comes that each participant trains the local data on their own device and keeps the raw data itself, while only sharing the outputs or the results, aggregated outputs or aggregated results, to the centralized server, without sharing the raw data that contains the PIIs. Having that said, we can definitely understand what are the key benefits of federated learning. First, we have an enhanced level of privacy. Second, we have an enhanced or improvement level of security. And we have a very advanced level also of regulatory compliance, because in this model, the data is located locally inside the territory, so there is no need to transfer the data across jurisdictions from a country to a country. And in that case, you're maintaining your typical compliance with your own laws and regulations. There are vast applications of federated learning. They take place in applications related to healthcare, finance, and mobile applications, and the IoT. Healthcare is definitely one of the most sensitive information that relate to a human or to an individual, and we can also definitely understand how sensitive and how important it is to maintain the highest level possible of privacy if that's the sort of data that is being processed for the training of the AI model. So keeping such data secure and locally on the device of the user itself or the server itself is definitely a distinguished level of privacy. Comes similarly all types of applications that take place that are being developed in this aspect. Allow me also to communicate to you some of the challenges that arise when implementing a federated learning model. Definitely, if the devices are scattered across the globe, maybe in more than one jurisdiction, or not at least in one physical location, there will be some sort of an obstacle in terms of communication overhead and the vulnerability to attacks and the complexity itself, because implementing federated learning requires sophisticated infrastructure and coordination in order to connect all the devices together. Now comes the point when we have to understand how does a federated learning model works. It works across several milestones. The first one, which is initialization, which is where a centralized server is created to hold the global model, and then this model is distributed to a list of participants who participate in training the AI model. Then comes the local training phase or milestone, which is every selected device or every trainer has to do their own training on their own local data according to the global model itself. And last but not least, the local model updates is after the conclusion of the local training. The device itself computes the updates, and then it sends those updates to the central server, where the central server absorbs those updates and adds them to the global model itself. So here definitely we understand the benefit. The data is stored locally, and also the beneficial updates or the output or the outcome is shared to the central server. Comes also after that the phase of aggregation, that the central server collects the updates from local devices, from each local device, and tries to compute them. And then comes the phase of federated averaging, which is to compute or calculate the weights or the average weight of every model update comes from every device, to be able to understand the input that comes from each user or trainer or device. Then eventually, and in the end, comes the global model update. After all the update comes from each local device, the aggregated updates are used to improve and advance train the global model itself, and then the global model is being sent back to each local device. So it's a two-side operation. One of the points that we have to understand in order to be able to enable a federated learning model is what we call the technical considerations. The technical considerations of the things that we have to put into consideration to be able to do that, to enable it technically. One of the most important points is the communication efficiency, because we understand communication comes from the devices scattered across the globe, and then we have to do another milestone or another check for the privacy of the data, which is what we call a milestone of differential privacy, which is adding some limited and calculated amount of noise to the data that comes from each device in order to make it more unknown or more ambiguous, if that word would work. Then we have to initiate, in parallel, of course, we have to initiate a security system to ensure the secure communication channels between all the devices, locally, in transit, and at rest as well. And then we have to handle the obstacles and the issues that could happen in every training device, because the powers and the capabilities of each device differ from user to a user. One of the things that can be taken as an example here, if we are developing an AI model, a federated learning model for an federated AI learning model for predictive text, in real life, every user that tries to tap in on their own screen, the local prediction happens, and then by the accuracy and the continuous learning of each user, or the continuous training of each user, is being submitted to the central server that comes and populates and collects updates from each device, and eventually the global model becomes more smart and more comprehending of the languages, the texts that could be written by any user across the globe, and then it's being sent back. So eventually, by more use you conduct on your own device, if you're one of the participants in a training model, you will find that your predictive text model on your device becomes more smart by time. There are also very important additional considerations that have to be taken into account in alignment with the technical considerations, which are the personalization. For federated learning, we do something that's called federated personalization, that enables personalization without data centralization itself. So each device can fine-tune the global model to better suit the individual's user data. Another thing is the scalability. For federated learning, it's designed to scale across millions of devices, so it can handle the diverse data that comes from each device. So scalability must be taken into account. Another thing that has been mentioned earlier, which is differential privacy, that depends on adding noise to the data so that it makes it more difficult to identify the user. I think also one of the things that have to be taken into account is some ethical considerations while conducting a federated learning model. There's nothing much to be said here, but as much as any privacy concern, you have to take care of your fairness, lawfulness, and transparency. For fairness, you have to make sure that your data is unbiased, and you put some sort of controls to minimize and address any potential bias risk. In addition to that, you have to be transparent with your end data subject or end user. You have to inform them what exactly you're conducting under their own personal data. As a conclusion, in the end of this short video, I hope you understood with me that federated learning represents a privacy preserving approach that tackles many of the privacy concerns that arose around AI generally and AI training specifically. By doing that and by following a federated learning approach, we ensure compliance with laws, we ensure compliance with regulations, we ensure the data is minimized, actually not handled at all in case if we apply the federated learning model in a proper way. And we ensure that each user or each participant feels safe about how their data is being processed in order to develop and train the targeted AI model. Thank you for being with me today, and please feel free to share any questions or concerns or thoughts that you have. And I hope you understand that I had to follow some written notes in order to provide the proper information to you guys. Thank you very much, and it was a pleasure to meet you all. Thank you.